Hi everyone. In today's video, we are going to go over the answer key for problem set 2. Problem set 2 really revolves around the idea of the organization and graphic presentation of data using strategies such as tables, figures, frequency distributions, and descriptive statistics. Question 1 asks us to actually fill out a table using descriptive statistics, the most common of which we use are proportions, percentages, cumulative frequencies, and cumulative percentages. And so with those things in mind, let's read question 1 together. A prison is currently housing 75 inmates. The table below shows the distribution of inmates based on their sentence lengths. Calculate the proportion, percentage, cumulative frequency, and cumulative percentage for each category. Please round your answers to the thousands place. So the information that you were given to start off this problem set were these two columns here. And so a couple of things of note. The first is that we are using intervals, which means that our rows are measured with a range. And so what we're seeing displayed here are those individuals who are sentenced to a length between 0 and 4 years, 5 and 9 years, 10 and 14 years, and 15 and 19 years. This second column represents our frequency, or how many individuals fell into each respective row. So with those things in mind, we can go ahead and fill out the rest of our table. In order to calculate a proportion, we need to take our frequency and divide that by our n, or whatever our total number is. And so I know, given the context of the problem, that I had 26 individuals who received a sentence length between 0 and 4 years. So all I have to do is take 26 and divide that by 75. I get 75 from the context of the problem above, which it states that a prison is currently housing 75 inmates, to get a proportion value of 0.347. Keep in mind that a proportion value will always be between 0 and 1. And so if you ever receive a value that is greater than 1 or less than 0, go back and check your math on that because something definitely went awry. We follow the same steps for the next 3 rows, simply taking our frequency and dividing that by our n total to get a decimal. Again, that proportion value has to be somewhere between 0 and 1. For those individuals between 5 and 9 years, it's 0.240. For our group that received a sentence between 10 and 14 years, it was 0.267. And lastly, the individuals who received a sentence length between 15 and 19 years, we have a proportion value of 0.147. Importantly, a way for us to check our math on this is knowing that our proportion value in the context of a descriptive table like this should equate to a final total of 1. Knowing that we're rounding, this is going to be an approximation. If you actually add these 4 figures together, you'll get 1.001. That's totally fine. It's an approximation, an estimation, and we know that's due to a rounding error. But it's a way for you to check yourself as well, knowing that you should be just around the value of 1. Moving on to percentage. Percentage and the relationship that has to proportions is pretty reciprocal. All that we have to do to convert from a proportion to a percentage is multiply our proportion value by 100. But because we're rounding here, we want a little bit more of a precise estimate. So you actually see me do the math here. Instead of just taking 0.347, multiplying that by 100, I'm going to go back to our original proportion calculation of taking our frequency value of 26, dividing that by our n of 75, and multiplying that by a value of 100 to get a percentage of 34.667%. I follow those exact same steps for each of these 3 rows below, so go ahead and check that against your own work. And know that your percentage, similar to your proportion total, should equate to 100%. If I took this total proportion value and converted that into a percentage, I know that 1 multiplied by 100 is 100. And so that's the relationship between these 2 respective columns. And so again, you can check yourself by knowing that each of these percentage values should equal approximately 100% total. Cumulative frequency. This is where we are sequentially adding each respective frequency from each row to each other. And so taking a look, our cumulative frequency for row 1 should match exactly what we have in the information that we are initially given. In this case, it was 26, so that's where I start off with here. The difference is now I'm going to add the frequency total from row 2 to my frequency from row 1. And so you'll see me here take 26, so again, the frequency from row 1, and add that to our row 2 frequency of 18 to get a cumulative frequency of 44. Now I need to take the cumulative frequency from row 2 and add that to our row 3 frequency. So I'm not just taking 18 and adding that to 20 here. We are accumulating this each row we get. So knowing that, I take 44, add that to our value of 20 from row 3 to get 64. And lastly, adding that accumulation of 64 from row 3, I add that to 11, which is our frequency from row 4, to get a total of 75. This should equate to the total you see in the row below, as well as the total N we have in our sample or the group that we are analyzing. I see that it does match up, and so that's how we know we did this correctly. Same idea here with cumulative percentage, except now we're using the column of percentages rather than frequency. So starting off, your cumulative percentage should always equate to what you see for your percentage category in row 1. And so these numbers should be the same. I see that they are 34.667%. I then add what my percentage category is from the next row. In this case, it was 24%. To that value to get a total accumulation so far in row 2 of 58.667%. I then add that to our next row percentage of 26.667 to get 85.33%. And lastly, adding in together our final percentage row of 14.667 should equate to 100%. I see that it does in this case. And so these numbers should match as well. Your row total from 4 should match your ultimate total of 100%. And so if you had any difficulty with this, feel free to rewind these steps and work through this and know that it would be the same regardless of what type of example I give you. So proportions formula, always going to be the same. Same with percentage and the steps for calculating both cumulative frequency and cumulative percentage. This information that you're initially given would change, but know that those steps remain consistent. So once you have this example down, you should be set to go. Moving on to question 2. Here's where we actually have a completed table, and I'm asking you to derive information from it. And so let's take a look at question 2. A survey was conducted with 235 individuals to examine their views on mandatory minimum sentences. The table below summarizes the result by age group. Please round your answers to the thousands place. And so what we see here are our various age groups. Again, we're working with intervals, and whether they support mandatory minimum sentences, they do not, or they don't know. They don't have a strong opinion either way. I see here that my ultimate total is 235, which matches what I see up here. And so again, this question is really asking you to now analyze a completed table. And so with that in mind, let's look at our first example here. What percentage of people ages 30 to 39 support mandatory minimum sentences? And so my key here is that I'm asking among the group of individuals who are ages 30 to 39. So I'm looking at this column here. Of these people, how many of them support or said, yes, I do support the use of mandatory minimum sentences? I see here that my total in this group of individuals that were surveyed was 60. Or in other words, I had 60 individuals in between the ages of 30 and 39 respond to my survey. 22 of them said, yes, I am in support of mandatory minimum sentences. I also see here specifically this question is asking us to calculate a percentage. And so with that in mind, I take 22, so my 22 yeses here, out of my total of 30 to 39-year-olds, multiply that by a value of 100 to get 36.667% of individuals between the ages of 30 and 39 support the use of mandatory minimum sentences. Moving on to our next example. What percentage of people who do not support mandatory minimum sentences are ages 20 to 29? So this is where the question shifts quite a bit. It's asking us first of the people who do not support mandatory minimum sentences. So I first have to go to my no group here, or this row total. So among all of those individuals who said no, how many of them are ages 20 to 29? I see here that my row total is 116. And of those 116 respondents, 26 of them were between the ages of 20 and 29. That's where you see me work out my math here. If I take 26 divided by 116, multiply that by a value of 100 to convert it into a percentage, I get a total of 22.414%. Next, what percentage of people ages 50 to 59 do not support mandatory minimum sentences? And so starting off again with those individuals who are between the ages of 50 and 59, so I'm starting with this column here. How many of them do not support mandatory minimum sentences? I need to identify my no's, which were 34 individuals. If I take 34 divided by my column total of 70, multiply that by a figure of 100, I get that 48.571% is our answer here. So what percentage of people ages 50 to 59 do not support mandatory minimum sentences? 48.571%. And lastly, what percentage of those who responded, I don't know, are ages 40 to 49? So I first start off with my row here of I don't knows. There's 18 of them total. And how many of them were in my 40 to 49 age group? I have 4. And so 4 divided by 18 multiplied by 100 is 22.222%. And so again, this is simply asking you to work with a table in which the data is already known. So it's a little bit different from what you see in question 1, but here's how you can actually read and interpret this type of statistical information. Lastly, with question 3, the graph below displays the number of arrests among a random sample of 105 St. Louis residents. I have a couple sub-questions here, but you must show your work to receive full credit. First, I'm asking you to estimate the proportion of individuals with 4 or more prior arrests and show how you arrived at this answer. So this is different from what we saw in question 2 of calculating percentages. We're back to proportions here. Right away, that should be triggering in your head that I should receive a value between 0 and 1. And so 4 or more prior arrests, I see on my x-axis down here that I have number of arrests. So I have some individuals that were reporting that they had 4 arrests and some that said 5. I have approximately 7 individuals who said I have been arrested 4 times, and approximately 3 individuals who said they were arrested 5 times. So those are my individuals with 4 or more prior arrests. I take 7 plus 3 to add those 2 categories together to get a grand total of 10, and divide that by our n, or the overall number of individuals who were sampled, which was 105, to get a final proportion value of 0.095. So green check there. I did end up with a proportion value between 0 and 1. Next, estimate the percentage of individuals who have no arrests. So now we're dealing back with percentages. This should trigger to you that you should have a value between 0 and 100. Looking here, I see that my individuals who said I have 0 reported arrests is 44. So if I take 44 and divide that by 105, which again is our n, and multiply that by 100, I get a total percentage of 41.905%. And our very last element here is estimate the percentage of individuals who have been arrested exactly 0 times and exactly 2 times. In this case, I need to take the amount of individuals who have been arrested exactly 0 times, so I can borrow that information from the one above. There were 44 of them. And those that have been arrested exactly 2 times, of which there were 17 of them. If I add that together, 44 plus 17, and then divide that by 105, which is our n total, I get 0.58095. But again, this question is asking for a percentage value, so I need to then multiply that by a figure of 100 to get a final percentage of 58.095%. You've reached the end of this problem set, and so compare this to the in-text comments that you received on Canvas, and if you still have any questions after this lecture video and review, please let me know. I am more than happy to meet with you either individually or during my drop-in hours. Let me know because this information will keep recurring throughout this semester. And so it's really important that you have a good basis on these descriptive statistics and how to use charts, tables, figures to interpret those statistics that are displayed. Again, any questions, feel free to email me or whatever way you're comfortable. Otherwise, I will see you in the next review video.